Okay, good morning to all of you, those who have joined in today's class. Uh, Before start my today's session, I must say that only one topic of module 5 is remaining. That particular part will not be discussed today. I shall discuss something else from module 5 and module 6 combined together. But after the module 5, and the next actually I'm talking about the next CA3 examination. Next CA3 examination will be considered on the basis of assignment, not not through Google form. Okay, so I'm going to give you some question, typically from hypothesis testing, or I may give you a system, a situation. I can give you a research paper to study, and from there I may ask a question. So that will be the next strategy. I shall give you a research paper. You will go through that, and on the basis of this, I'm going to set one. Along with the research paper, I'm going to give you the questions. So you will study a research paper. You will read them out. You will go through the research paper by yourself, and corresponding questions which I'll be sending along with the research paper, you will try to answer those. And then I will set a deadline, and you will submit that in the Google Classroom, or or through any other means that will be discussed later. That will be told to you later. The best way to submit the assignment is through Google Classroom, so that I can download and save it and check it individually. So the next assignment will be, next CA3 will be based upon that. So I thought taking examination in Google form is all right, but if it is a matter of hypothesis testing and you are learning so many things about testing, then uh, the essence of this will be missing if I take the examination in Google form. That there is no logic in taking examination through Google form. Our syllabus is almost over. We are almost done with the syllabus. So there is no hurry. I'm not in a hurry. University has not given us the deadline for CA1 and CA2. So I have taken the CA2 examination so far. So we are all a bit kind of relaxed. I think you are also kind of relaxed. So you'll be having much time to go through research paper, and you will go through that, and subsequently will answer the questions said by me. Okay, so you will I thought you would be enjoying that process of taking the examination also, because whenever a student uh, gets chance to study an actual research paper, then I think this is kind of a bit he will be kind of a bit motivated regarding the subject. Okay, so I hope that you all agree with my decision. uh, any other thing which comes to your mind, you can discuss with your uh, class representative, and he will talk to me. Okay, so let's begin my today's session. My today's session I'm going to discuss two problems only. One based upon Z test and another based upon T test. Meanwhile, when I am taking the classes on these tests, you also compare what is being done in the class with the syllabus, and you try to keep a track of what is being completed in the syllabus. Okay, so it is also it is also a kind of duty from your end. My today's topic first situ my today's my today's first topic is the first situation is hypothesis testing concerning difference of population mean, which will be done by Z test. Okay, so So this is the situation which I was going to discuss. It's about hypothesis testing concerning difference of population, and for that I shall be using Z test. So what is the situation? Suppose we are selecting two samples, capital Xi and capital Yi, of equal size from populations which are assumed to be normal. The populations which are assumed to behave like a normal population, or the population distribution is normally distributed. So both of these populations from which the samples are assumed to be drawn uh, will be having some mean, say mu x and mu y, and sigma x square and sigma y square. Okay. Now you see, you are drawing a sample from a population, let's say population of males and population of females, population of male students, population of female students, population of students of Techno India group, population of students of heritage group, like this. Now, I don't know whether these two populations behave normally or not. Okay, but I shall assume that the population distribution with respect to Techno India group is also normally distributed, heritage group is also normally distributed, and we shall assume two different means and variance for the two groups from which the samples are being chosen. Now our study is to check whether the population means of these two groups are same or not. Okay, if I can show you that the population with respect to the heritage group is population mean with respect to the heritage group and population mean with respect to the Techno India group, they are same. So in that case, although the samples differ, samples have been drawn from apparently from two different populations, ultimate conclusion will be that there is actually no significant difference between the heritage group of students and Techno India group of students. But in due time, if I get that my H1 is true, then in that case, I must say that there is a significant difference between the heritage group of student and the Techno India group of student. And then we are supposed to find the difference, why the difference is there. Okay. And you know, the population means cannot be measured. Population means will be actually assumed, and hypothetically that will be tested. The best estimate of population means are the sample means. So to estimate mu x, we shall take the help of x bar, which is corresponding to the sample 1, and y bar, which is corresponding to the sample 2. Now, it seems reasonable that the null hypothesis should be rejected when x bar and y bar are far apart. What does it mean? Means if I can find that the two sample means are widely separated, the two sample means are widely separated, then this null hypothesis then I can reject the null hypothesis. But if the sample means are not widely separated, then I'll say that there must be some kind of consistency between the two population means. Okay, but technically there are some rules by which this can be done. The test statistic which I shall consider over here is of this form. Okay, so since population are normally behaving, that means we shall consider the Z statistic, and the Z statistic, look at this particular structure carefully. The Z statistic, what is the form of the Z variable? Z variable is always in its standardized form, and in standardized form, what we write? In standardized form, we write x bar, the value minus the mean divided by the standard deviation. Here, in place of x, I have considered x bar minus y bar, the difference between the two sample means. From this difference, the difference of population means will be subtracted. So minus mu x minus mu y has been written. Whole thing divided by sigma x square by n plus sigma y square by m. Now you see the sample sizes may be different. If you look at the formula carefully, the formula tells you many things. Okay, so I didn't write n and n over here. By writing n and m, two different letters, I mean to say that the sample sizes you are considering, they may be of different size. Okay, although it is desirable to choose a sample of equal size, but to generalize our testing of the hypothesis, we can vary the sample size also. So there is a provision of doing that. Yesterday we did the pair t-test. In pair t-test, there is no provision of varying the sample size. You have to keep it same. But here we have provision of varying the sample size. Now, in the null hypothesis, we have assumed that the two population means there is no significant difference between the two population mean. And you know that every test statistic is actually based upon the null hypothesis assumption. Okay, so in that, under these circumstances, if we assume that indeed mu x and mu y, they are same, then under the null hypothesis, the formula will reduce to this particular form. The difference mu x minus mu y will vanish. So we'll get x bar minus y bar by root over sigma x square by n plus sigma y square by n. This is my statistical tool by which I'm going to analyze the situation. Fine. Now, what is the way of drawing the conclusion? There are various ways, but the most universal way of drawing the conclusion in case of z-test will be to take the help of p-value, and you already know what p-value is if you have gone through my earlier videos. So let us directly go to the problem section. In the problem, it is mentioned that two new methods for producing a tire have been proposed. The manufacturer believes there will be no appreciable difference in the lifetimes of tires produced by these methods. To test the plausibility of, extremely sorry, there is a network issue today. Sometimes it happens, I can see. Sorry, for it is beyond the control. So two new methods for producing a tire have been proposed. The manufacturer believes there will be no appreciable difference in the lifetimes of tires produced by these two methods. So if we consider the sample of tires as sample 1, and these are the tires which are actually being manufactured by method 1 at location A. This is my sample 1. Okay, so this sample has size 9, and another sample of tires which are being manufactured in the location B is sample 2, and its size is 7. So you can say that the sizes of this size of these samples are small because both of these 9 and 7 is less than 30. So is it a small sample test? Whether it is small sample or large sample, now it doesn't matter actually, because in each of these samples, large or small, under certain circumstances tend to follow normal distribution. So you may sit relaxed and you can very well apply z-test in any of this case. But the formula you are choosing, that has to be appropriate. So you may ask me one question, sir, if it is a small sample, should I go for t-test? Only the sample size doesn't define whether you are going to select this test or that test. Some other issues are there which I'm going to discuss right now. How to select your statistical tool. Other condition has to be verified. Okay, so what are these conditions? I'm coming to this point. Now, what is written? The first sample of tires is to be road tested at location A and the second at location B. It is known from previous experience that the lifetime of a tire tested at either of these locations is normal random variable with mean life due to the tire, but with a variance that is due to the location. Specifically, it is known that the lifetimes of tires tested at location A are normal with a standard deviation equal to 3000 kilometers, while those tested at location B have lifetimes that are normal with a standard deviation of 4000 kilometers. So standard deviations are actually varying. Now you see, as I said to you just now, that there are some other conditions which has to be taken care of before you select your appropriate test statistic to decide on the null hypothesis. One of these condition is that you can see very well that we have some kind of information regarding the population standard deviation. One population standard deviation is given to be 3000 kilometers. Another population standard deviation is given to be 4000 kilometers. If we apply t-test, in t-test there is a condition, and what is that condition? The condition is we shall not be having any idea about the population standard deviation when we apply t-test. In those scenarios, we apply t-test. But here the population standard deviations are known, so t-test will not be appropriate. We are going to apply the z-test. Okay. But below, I have selected another problem where you will find that under what circumstances t-tests are applied. And now you're going to understand that there is indeed a difference between, although in the testing of single mean, there was no significant difference between the two tests, Z and T, but now you're going to see that yes, there are significant difference between the two things. So I'm coming to that point gradually if the time permits today. So these are the samples of the tires. First sample size of the the tires situated at location A is 9, and the second sample size is 7. And we are going to calculate the mean of these tires. Okay, so we have calculated from, if I consider this to be X bar and this to be Y bar, we have calculated the mean X bar from these values. So all those values have been added and divided by 9. So this value has been written over here. And the second is Y bar, which is obtained by calculating all these values and dividing by 7. Okay. So the means of these tires have been calculated, X bar and Y bar. Now, variance. In variance, standard deviation of the tires are actually given to be 3,000 kilometers and 4,000 kilometers. And you see carefully that in the table, below the table, it is mentioned that all these values, 66.4 and 61.6, the units of these variables are units of 1,000 kilometers. So you are actually, they have actually mentioned that 66.4 into 1,000 kilometers like this. So we are considering only the numerical value over here. The units are actually being omitted, because if you consider the unit or if you do not consider the unit, the result is not going to change. But if you consider the unit, the values will be so large that we shall not be able to tackle them, even by calculator also. So while writing the standard deviation of the two populations, I have not written 3,000 and 4,000. Okay, I have written 3 and 4 only. So don't get confused. Why it is written as 3 and 4? Obviously, as per the situation given, my null hypothesis will be that there is no significant difference between the two population means of the tires located at with respect to the location A and location B. So I have assumed this, and against the null hypothesis that no, there is a significant difference between the population mean. And now at this juncture, you can very well say that these two population means this particular testing is a two-tailed test, because when we write mu x not equal to mu y, that means there are two possibilities, either mu x greater than mu y or mu x less than mu y, which is not mentioned specifically in the problem. Okay. Under H0, we already have the formula with us. So I have applied this particular formula. The means are known, the X bar is known, the Y bar is known, but you see the term mu x minus mu y will not be there. Why? It has already been told to you that if we consider mu x equals to mu y, that means mu x minus mu y will vanish. So under the null hypothesis, we are getting X bar minus Y bar in the numerator only. And in the denominator, we have sigma x square by n and plus sigma y square by n. So sigma x is 3, so sigma x square will be 9 by sample size, which is also 9, plus sigma y is 4, so sigma y square will be 16 by sample size 7. So after calculating this, we have got 2.192. To draw the conclusion, as usual, we are going to take the help of the p-value. What is the definition of p-value? P-value's definition, I'm again repeating, because p-value is one of the most important things which is used in the statistics. P-value's definition tells us that it is the lowest significance level at which the null hypothesis is rejected. It is a behaving kind of, it is an infimum kind of thing. There may be various significance level at which you can test your hypothesis, but out of the at all these significance levels, you may reject your null hypothesis. Out of all those significance levels at which the null hypothesis will be rejected, the minimum of those, minimum of that significance level is say alpha or p, that p will be termed as p-value. So p-value is actually behaving like infimum, okay, greatest lower bound. So whenever we are going to select a level of significance which is greater than p-value, obviously my null hypothesis will be rejected, because p-value's definition is saying that p-value is the lowest significance level at which the null hypothesis will be rejected. So if you consider any significance level greater than p-value, then obviously your null hypothesis will be rejected. It's quite obvious. So but if you can ask me one question at this juncture. So why, since I have got the this p-value, after the calculation of p-value, I am actually skipping this particular part because it has already been told to you how to calculate the p-value. We have this particular formula, probability of mod z greater than or equal to nu. What is nu? Mod nu. Mod nu is the value which is calculated from z over here. And it can be written as twice p of z greater than or equal to, in place of nu I have substituted 2.192, and from the statistical table I have got 0.0286. Now since we have been asked to check the significance at 5% level of significance, so you can very well tell me, sir, what why are you selecting p, and since I have got the p value as 0.0286, so you can ask me this question. So sir, why are you selecting 5% level then? Because if you select 5% level, then your alpha is 0.05, which is greater than 0.02. And obviously the null hypothesis will be rejected, because you know any level of significance greater than this p-value, the null hypothesis will be rejected. So you can suggest me that, sir, you could actually take the help of 1% level of significance, because if I consider 1% level of significance, the alpha will be 0.01, and in that case the alpha will be lesser than the p-value. This is very interesting part. First of all, the answer to your first question is that I am actually taking the help of this p-value, this level of significance, that is 5%, because it is mentioned in the problem. But suppose it is not mentioned in the problem, then it is your choice what to select. You can take the help of any significance level which you think best suited. Okay, so you see, if I consider the same problem, I'll find that at 5% level of significance, you are going to reject the null hypothesis. But if I select alpha equal to 0.01, you are going to accept the null hypothesis. And that's why one day, probably I can't remember when, I told you that statistics is a very manipulative subject. If you want to negate something, you can negate by choosing the appropriate level of significance. And if you're going to consider something, then also it can be done. And both of these things, interestingly, negation and the consideration, both of these things can be done on the basis of same situation. So statistics is kind of manipulation. We are manipulating things. Okay, so whatever you see in the newspaper nowadays are all manipulations, because the source, the methodologies, the statistical tools they have used, we have not been informed about that. And why should we be informed? Because we are laymen's. Newspapers are for all, not for statisticians only. So that's why I have decided now, as there are 40 participants, in the beginning of the class, I told to the students that CA3 examination will be kind of different one, not with respect to the Google form. I am going to give you a research paper. You will study the research paper. On the basis of the research paper, I shall give you questions, and you are going to answer those questions. Okay, so I have not prepared this because it is time taking. So in this way, I'm going to take the CA3 examination. I will set deadline. Once I prepare the question, I shall inform the class representatives, and then we shall set a deadline, and you will submit through Google Classroom. Okay, so this is how I want all of you to take the actual essence of statistics from practical examples, not by bookish examples. Okay, the research has already been done. That paper will be selected. Nothing new in this, but the questions which I'll set will be based upon that research paper. So when you will be studying that research paper, then you will find that you will feel a feel good factor will come inside you. Okay, I hope that you will enjoy it. Okay. Second situation is hypothesis testing concerning difference of population means. Same situation. In the previous case, I have applied z-test, but here I'm going to apply t-test. Now, question is why I'm going to apply t-test. So let's read the question first of all. Problem number 2 says 22 volunteers at a cold research institute caught a cold after having been exposed to various cold viruses. Okay. A random selection of 10 volunteers were given tablets containing 1 gram of vitamin C. These tablets were taken 4 times a day. The control group, consisting of the other 12 volunteers, was given a placebo tablets that looked and tasted exactly like the vitamin C ones. This was continued for each volunteer until a doctor, who didn't know whether the volunteer was receiving vitamin C or the placebo, decided that the volunteer was no longer suffering from the cold. The length of time the cold lasted was then recorded. At the end of this experiment, the following data resulted. Do these data prove that taking 4 grams of vitamin C daily reduces the time that a cold lasts? At what level of significance? Now you see these volunteers, okay, they have been chosen and they are the guinea pigs on which the thing is being tested. Apart from the volunteer, there is one interesting people are there, and it is a very, since statistics is not taught to you engineering students in its entirety, various things are there, various criteria are there in the statistics which has to be taken care of. Okay, we discuss a very few portion of the subject as per the syllabus and because of the time limitation, but we do not give the idea in its entirety because we do not have that much of time. So if you, that's why these online courses like provided to you by Coursera and edX, these are good because they prepare the course curriculum in its entirety. So what you are missing in the classroom, you can get it from Coursera. What you are not understanding in the Coursera, you can get it from the classroom. So both of these things are very important. Okay. So in the future, if you are actually applying for any statistical course in any online MOOCs platform, then you can take help from me if you don't understand any particular part. So if you go through that, if you go by those courses, you will see that they will teach you the control group. The definition of control group in its entirety will be taught to you. What is control group? Whenever we test something on guinea pigs, or suppose the COVID vaccine are being prepared and we are actually selecting a sample of human beings on which I'm going to test this vaccine, I shall keep a control group beside, and that control group will not be told anything about my experimentation. I shall not reveal anything to them that I'm going to actually test a vaccine that we are trying to manufacture for dealing with the situation of COVID-19. So that control group, they know that they are going to get some kind of medicine, but they will not know that instead of getting that medicine, actual vaccination, they are going to get a placebo. What is that placebo? Placebo is nothing. Placebo is just a kind of thing which is not actually my appropriate medicine. So if I talk about vaccination, the vaccine is my medicine. A placebo can be any other doses, which is not at all related to this kind of vaccination. I want to test how this actual group of people on which the vaccine has been applied are behaving with respect to the control group who has not got the actual medicine, rather who have got the placebos. Okay, so control group will be set, and control group's behavior with respect to the actual group's behavior will be compared together. So such kind of things, these two types of groups have been selected over here in this particular problem. And the doctor, the doctor who is actually testing the patients after getting the doses, the experimenter is sending, after putting the doses in them, the experimenter is sending both the groups, control group and the actual group, to the doctor, the physician. The physician doesn't know about anything, which particular volunteer gets what, with everything has been mixed up. If the physician is manipulated, if I say to the physician that this is the group who has got the placebo and this is the group who has got the actual vaccination, then the conclusion drawn by the physician will not be appropriate. So we have mixed up everything and we have placed them in front of the physician, and physician is actually testing whether this particular tablet or vaccine, whatever you say, is effective or not. So such data has been put over here. The set of patients who has been treated with the actual medicine, that is vitamin C, and the set of patients who have got the placebo in the name of the vitamin. So we want to test whether these two data are actually behaving differently or they are same, whether there is any significant difference between the two populations or not. But if you carefully observe, what is missing over here is, what is missing in this particular case is, you do not have any idea about the population standard deviation. In the previous example, the idea of population standard deviation was there. 3,000 kilometers, 4,000 kilometers, we knew what is population standard deviation. But here population standard deviations not known. And I told you that selecting a particular statistical tool actually doesn't depend only on the size of the sample. It also is dependent on other aspects. And that is the other aspect, that if population standard deviation is, since population standard deviation is not known, you will not be able to apply z-test for difference of population. And now you are going to apply the t-test. T-test has got this particular formula. Everything remains same. Everything remains same. But you see that sample sizes are different. So I have written 1 by n plus 1 by m. But in place of sigma x square and sigma y square, I have written a quantity which is called st square. And the st square is given by this particular formula. Carefully observe the formula. This is about the sample population, sample 1, and this is about the sample 2. And these two summations have been divided by the quantity sample size 1 plus sample size 2 minus 2. And therefore, since we are going to estimate the population standard deviation by st square, the degree of freedom is n plus m minus 2. Okay, so the divider in the estimate of population standard deviation is actually defining the degree of freedom, as you can see. Here I have written mu x. Mu x is the population with respect to those patients, the population mean with respect to those patients who have got the actual medicine, and mu y is the population mean with respect to those patients who have got a different placebo. I have written here mu x less than or equal to mu y intentionally. I could have written mu x equal to mu y. There, the conclusion, drawing of the conclusion wouldn't be different then. But here you see the appropriate assumption would be this, because if I consider that mu x is the population on which the vitamin C has been applied, and mu x is the mean effect, and mu y is the mean effect of that group who has got placebo. So we expect that either the medicine is not effective in this group, the mean is lesser than that, or it is equal to that. I cannot expect mu x is greater than or equal to mu y, because it is, then I am overconfident. And in statistics, overconfidence is actually not acceptable. Avishruti Hazra 072 has raised hand. I don't know whether she wants to ask any question or not. If you want to ask any question, then you can write in the chat box. Okay. I'm saving your chat once again, just to be on safe side. I'm almost done with my today's class. I'm going to give the finishing touch only. So you see, I have calculated the mean, and the mean of the two groups, the control group and the actual group. The mean has been calculated. I have not shown you the calculation because it is, you can do it by yourself now. You are in a position that you'll be able to do it. So it will be a kind of homework or practice work that you try to find from the table the X bar and Y bar, and also you try to calculate this quantity. I have shown everything, but you try to calculate this quantity ST square. Okay, and ST square has come out to be 0.689375, or you can say ST is this, and therefore T is calculated to be minus 1.898. Now, when we consider t-test, to draw conclusion, we shall not take the help of p-value. P-value is actually appropriate to be used in the z-test. Otherwise, we shall take the methodology of drawing conclusion which we applied in the last class. We will take the absolute value of t. Even if it is positive, we will show it that we are taking the absolute value. And then if you find that this absolute value is greater than the tabulated value, then in that case, I shall reject the null hypothesis, or otherwise we shall accept the null hypothesis. And the t value can be obtained from the statistical table, which I shared with you. And that particular table, you will find the degrees of freedom and the level of significance. But in your present circumstance, your degree of freedom is how much? 20. N plus m minus 2. So at 20 degrees of freedom, at 5% level of significance, you are going to select this particular tabulated value. Now, in the question, it was given at what level of significance. So it is, as I told, it is up to you. If you want to reject it, then you choose the appropriate level of significance. If you want to accept it, you choose the appropriate level of significance. So I have selected 5% level of significance because I like to be in the 95% confidence limit criteria. Okay, if you want to keep yourself in the 99% confidence limit criteria, you can keep yourself. So after getting this p-value, this tabulated value, I found that this modulus of t is greater than 1.725. And according to the rule, I am going to reject the null hypothesis, and I'll say that no, this two population means are significantly different. And yes, my vaccine, the persons who are getting vitamin C, the medicinal effect on those persons are much more higher than the medicinal effect on the persons who are getting the placebo. So see, this is the thing which is being done by Pfizer, Moderna. This is the thing which is being done by Sputnik. This is the thing which is being done by Serum. Everybody is playing this kind of game with their COVID-19 vaccination. This is the thing they are doing. Okay, so if you write, say, it's a very funniest. The funny thing is that suppose you want to write, if you ask me, sir, if I write mu x equal to mu y, suppose you are asking me, sir, if I write mu x equal to mu y over here, and if I write mu x less than mu y, will the answer vary? The answer, my reply will be no. The answer will not vary, because I shall do the same things. I will apply the x bar. I shall find the x bars and y bars and this. Everything will come. But if you are the vaccine manufacturer, will you be stupid enough to write that your mu x is less than mu in the alternative hypothesis? Then if the null hypothesis gets rejected, and if you write mu x equal to mu y, then you are also kind of stupid, because you are saying that whether you apply COVID-19 vaccine or placebo, the effect will same. So will you be stupid enough to write these types of null hypothesis and alternative hypothesis in your analysis? I think no. I think we are not stupids, and those companies are also not stupids, and therefore they design their null and alternative hypothesis in this particular way. So that's why I have written why, this question why over here. This is not a question mark, this is an exclamatory sign. After the class, if you get a time, just sit for 10 minutes and think what is happening outside, what is actually being happening, what to believe and what not to believe. I have stopped reading newspaper nowadays. I read newspapers regularly, but if I can see the newspapers is showing me a kind of statistics, I don't read this because I don't believe. Always believe, get the thing which you are doing by yourself, which you are seeing by yourself, where every aspect is clear to you. You can believe a research paper. If corresponding to a newspaper article, you get the appropriate research article, it is better to get the headline and try to get that particular research paper and read it from the research paper. Then at least you will be able to know what methodologies they are using, what statistical tests they are using. Okay, so since you are learning statistics, I'm telling this kind of thing. Obviously, you don't say this kind of things to your relatives and parents, because they are not learning statistics. So they will laugh at you and they will say, you are student, you study. Well, I do not have, we don't have this amount of time to go through. मेरा उम्र नहीं है अभी कुछ सीखने का, कि तुम्हारा उम्र है तो तुम सीखो. So you try to get the essence of this by going through the research articles. And as I said, that the CA3 examination will be on the basis of the research article and corresponding questions. So I hope that I am able to percolate the message to you and you are able to understand the today's topic. Tomorrow, if I go to college, if I have to go to college, then probably I shall not be able to take the class. But if I can skip the college tomorrow, then I'll be able to take the class. Now, I